Drivers can find themselves in situations such as these due to bad weather or sudden obstacles. In all these situations, you can rely on the support of tried and tested Mercedes-Benz technology to help you deal with such real-world driving conditions. ESP, the Electronic Stability Program, provides enhanced traction and steering control under different kinds of driving conditions. With ABS, ETS, and ASR, Mercedes-Benz has led the way in the field of driving dynamics technology and safety systems. The ESP system effectively combines the functions of all three of these systems. At the same time, it incorporates additional sophisticated sensors and advanced electronic circuitry to register and evaluate both the actual behavior of the vehicle and driver input. It can help keep the car on course when braking and accelerating, and also for the first time when cornering. While the system significantly reduces the chance of losing control of the vehicle, it cannot change the law of physics, and therefore cannot guarantee stability and control under all conditions. Basically, ESP is capable of stabilizing the vehicle by controlling the brake pressure on all four wheels individually. This may sound unusual, but it's quite logical if we consider the physical principles involved. In this simulation, the vehicle on the right shows what could happen when a vehicle without ESP takes extreme evasive action. ESP is designed to intervene, helping to counteract undesirable forces and stabilize the vehicle when oversteer or understeer threatens stability. If a vehicle oversteers, this means that it is rotating too fast about its vertical axis. The rear end will try to break away and swing out. The shaded motion shows the ideal course of the vehicle into the corner corresponding to the steering angle input from the driver. When oversteer is detected, ESP employs precisely measured braking pressure to the front wheel and generates a force which helps correct the instability. Here is the same sequence again, this time in slow motion. Understeer means that the vehicle is rotating too slowly about its vertical axis. That is to say, it does not keep pace with the turning of the steering wheel and will continue to plow straight ahead. In this case, ESP helps stabilize the vehicle by braking the rear wheel, creating a force which returns the vehicle back onto its intended course. Here we see this once again, in slow motion. Let's now look at the sensor system, which monitors the behavior of the vehicle, providing information which may cause ESP to intervene. The sensors register the actual behavior of the vehicle, which is forwarded to the control module. The control module, in turn, compares this data with the expected behavior to determine if an oversteer or understeer condition is present. Sensors and electronic components are shown in red, the hydraulic system in yellow. Some of these sensors may already be familiar to you from the ABS and ASR systems. The wheel speed sensors measure the speed of the wheels and determine the vehicle's rate of acceleration or deceleration. The measurements are compared to reveal any excessive slip. The steering angle sensor detects the direction the driver is steering the vehicle. The lateral acceleration sensor informs the electronic control system of the side-to-side acceleration of the vehicle. The yaw rate sensor, which is derived from aerospace technology, recognizes the vehicle's speed of rotation about its vertical axis. The brake pressure sensor measures the brake pressure applied by the driver. All this information is fed by a real-time data line to the control unit, which evaluates the inputs and, if necessary, initiates a stabilizing sequence. This stabilizing sequence is adaptive. That is to say, the interventions are continuously adapted to the constantly changing movement of the vehicle. The hydraulic system is similar to that used in the ASR and ABS systems. It has been adapted to take into account the fact that the wheels operate individually. As with all Mercedes-Benz systems, the warning light, a yellow triangle, is integrated into the speedometer. In critical braking situations, as here for example, where the vehicle is forced onto the road's shoulder, the information registered by the ESP system allows it to act more quickly, resulting in more stable braking. Thanks to ESP, braking pressure can be varied individually at each wheel. In this way, braking effectiveness can be better adapted to surfaces that offer different grip. Let's look at the stabilizing action of ESP once again in slow motion. ESP provides stability and maximizes available traction when accelerating, regardless of changes in the road surface, or when starting up from standstill. This function is similar to that of the ASR system. When driving with snow chains, or when starting on a loose surface such as gravel or sand, the forward effect of a slipping wheel can be useful by providing for some traction at lower speeds. This can be selected manually by depressing the ESP off switch on the console. In this mode, the ABS braking system remains fully active, and traction assistance is unaffected since the ASR system reverts to ETS. The new ESP traction system significantly improves vehicle stability, whether the critical situation occurs when accelerating and braking, when traveling at a constant speed, or cornering. Here, once again, we see how the brief braking pulses are applied to individual wheels, helping to stabilize the vehicle in the event of understeer and in the event of oversteer. In the case of an unbraked evasive maneuver such as this, ESP detects the tendency of the vehicle to break away and stabilizes it by intervening in the brake system, as we have seen, in some cases also reducing the engine torque. Mercedes-Benz drew on its long motorsport tradition when developing ESP. The system caters ideally to sportier drivers too. But whatever your own personal driving style, driving safely has always been the most pleasant way of enjoying your Mercedes-Benz.